am Dr. G. Karthikeya Lakshmi, working as Head and Associate Professor in the Department of Computer Science, aided V.V. Vanepermal College for Women, Virudhunagar. Now let's see what do you mean by geometric transformation. Geometric transformations are used in computer graphics to alter the coordinate positions of the object. You can use them to change the position, the orientation, the size and the shape of the object. But what is the use of a geometric transformation? The geometric transformation can be used in animations, simulations, and in the design of different layouts such as circuit layouts, pipeline layouts, and building layouts. Let us see what are the different transformations available. We have three basic transformations as translation, scaling, rotation, and other transformations available are shear and reflection. Translation changes the linear position of the object. Scaling will change the size of the object. You can increase the size or decrease the size using the scaling. Rotation will change the angular position or orientation of the object. Shear will be shifting the object in such a way that one layer of the object is sliding over the other. Reflection flips or creates the mirror image of the object. Now let us see the basic transformations one by one. First, let us see the translation. Translation does not change the size and the shape of the object. So, it is called as a rigid body transformation. Translation will be changing only the linear position of the object. We can move the object to different positions by adding the translation factors Tx and Ty. Tx will be the x translation factor, Ty will be the y translation factor. If we are adding the x translation factor to the x coordinate of the object, it will be changing the x position of the object. When you add Ty to the y coordinate of the object, it will be changing the vertical position of the object. So, the translation factors Tx, Ty, this pair is called the translation vector or shift vector. So, here is an illustration of the translation. We can translate the object along the horizontal direction, vertical direction, or you can move it diagonally. Anything is possible with the help of the translation factors Tx and Ty. The translation can be represented by equations x dash is equal to x plus Tx and y dash is equal to y plus Ty. So, x dash and y dash are the translated points coordinates. The original point is represented by x comma y. We can write the translation in the form of a matrix as T equal to Tx Ty. But Since translation is an additive transformation, when you are writing in a 2 by 2 form or a 2 by 1 form, it will lead to a multiplication. To avoid that, we are using homogeneous coordinates and we are representing the translation by some 3 by 3 matrix. Here we are seeing the Tx as a positive value. When Tx is a positive value, the object will be moved towards the left. When Tx is a negative value, it will be moved to the other side. Depending upon the Tx value, say when Tx is equal to 3, we are moving the object towards the right, and when Tx is equal to minus 3, we are moving the object towards the left. Then when we are changing the Ty value, it will be moving the object upwards or downwards depending on the sign of Ty. When Ty is negative, then the object will be moving downwards. When Ty is positive, the object moves upwards. But in the computer graphics, the origin will be in the top left corner. So, these Ty's will have a different effect. Here we have the translation matrix represented in 3 by 3 form. The Tx and Ty are occupying the last column. So, when we form a composite translation matrix, rotation matrix and scaling matrix, if you want to apply all the 3 transformations to a single object, then we can combine all the 3 transformations into a single 3 by 3 matrix. For that, we are using homogeneous coordinates and the translation matrix in the 3 by 3 form like this. Next, we'll move on to the scaling. Scaling is a transformation which is used to change the size of the object. We will be increasing the size of the object or decreasing the size of the object using scaling factors Sx and Sy. When we are applying this scaling factors to the original point of the different vertices of the object, then we will be having a resultant matrix as a object represented in the scaled up or scaled down form. So, if we have a polygon with 5 sides, to all the 5 endpoints or the vertices, we will be applying the scaling factors, and this will lead to a increase or decrease in the size of the object. So, scaling equations can be written like this. When x, y is the original point, Sx, Sy represent the scaling factors. Then x dash, y dash can be formed by multiplying the x coordinate of the original point by the x scaling factor, and the y coordinate is multiplied by the y scaling factor. So, we can say Sx, the scaling factor, it changes the width of the object. Sy, the y scaling factor, changes the height of the object. So, if you want again to form a composite transformation matrix, we may represent scaling by a 3 by 3 matrix in this form. Sx 0, 0, 0, Sy 0, 0, 0, 1. The same thing when you don't want to have a 3 by 3 representation, you can use a 2D representation or a 2 by 2 representation as Sx 0, 0, Sy. So this is again an illustration of the original object and the scaled up or scaled down object. When Sx is equal to Sy, that is, when both scaling factors are equal, then we have a uniform scaling. The width of the object will be increased or decreased in the same proportion as the height of the object. Whereas when you have Sx not equal to Sy, the width and the height will be changed in different proportions, and we call this scaling as a non-uniform scaling or a differential scaling. Again, when Sx or Sy is less than 1, we have a scaling down. The size of the object will be reduced. When Sx and Sy are greater than 1, the size of the object will be increased. So, we will be using this scaling up and down effect in the zooming up and down. What will happen when Sx and Sy are equal to 1? Nothing happens. The size of the object remains the same. Now we move on to the third one, rotation. Rotation is a two-dimensional transformation that is applied in the 2D plane or the xy plane that changes the angular position or orientation of the object. How will you apply the rotation? Here is an illustration. The point, original point is x comma y and the rotated point is x dash comma y dash. So, the angle by which the object or any point or line is rotated is now given by the theta. How will you find out what is the equation of the rotation? Let's move on to the next slide to find that. So, we are going to apply the rotation about one pivot point. Usually, we will select the origin as the pivot point and we will be applying the rotation. If you want to move the object to a different position, that is, if you want to rotate about an arbitrary point other than the origin, first we will be transforming the object in such a way that the lower left corner of the object coincides with the origin. Then we perform the rotation. After that, we move the object back to the original position. So, when you have positive values of the rotation angle, we will be rotating the object in the anti-clockwise direction. Whereas the negative values for the rotation angle will be rotating the object in the clockwise direction. Here is the equation for the rotation. So we have x dash y dash as the rotated point, x y as the original point, theta is the angle of rotation. We have x dash is equal to r cos of theta plus phi and y dash is equal to r sin theta plus phi. In this, we are going to substitute for x. X is equal to r cos phi, y equal to r sin phi. Substituting that, we will be getting x dash is equal to x cos theta minus y sin theta, whereas y dash will be equal to x sin theta plus y cos theta. So where will you use the rotation? Rotation can be used in simulation of the solar system. If you want to move an atom, the atomic motion can be simulated using rotation. Like this, any orientation change in the angular position can be implemented using the rotation. So we have seen some basic transformations like translation, scaling and the rotation. Scaling and the rotation are done about the origin. Other transformations are also existing. They are shearing and reflection. Thank you for watching the video.